everyone, welcome back to my YouTube channel. Okay, so today I follow on from this custom stainless capsule. This project, this idea I created to assist the build of my large battery pack for my Green Beast e-bike project. The design and the manufacturing processes of this capsule was the last video, the last project uploaded to my channel. So this small project was created to mimic the uniquely shaped dual suspension bike frame to a T. In this video I will be demonstrating the plans with a thorough discussion, completing the configuration stage of my battery pack to set the pack to 72 volts, 84 volts maximum. So 72 volts nominal and 84 fully charged, whilst having a massive capacity of 50 amp hour. So what I have here is, well, I'll just show you. So I have 200 cells sitting on this bench. Oh, there you go. I'm not going to drop them here, but 200 cells. There's another 70 there, there's 130 in this box. So I'm now going to configure my battery pack, and then the next video that follows this one will be the actual demonstration of the build. So let's go inside here and get started. Okay, so I am ready to rock here. I have a lot to get through. So hopefully the camera doesn't go out of focus here. It doesn't like the white background. Sometimes you might see it sort of auto focusing. I think it's to do with the light here being reflected back up into the lens. So what I have here is the plans that I have set out for my e-bike battery, or my Green Beast e-bike battery build. So I'll start off with it in this position. So what I have here on the left is the right hand side of the battery pack. Here we have the left hand side of the battery pack. So this is bank 1 and this is bank 2. The reason I have drawn it back to front is because in this position, this is where the two banks will be positioned on the bike. So I'm going to just demonstrate that, and then we'll get into the actual sort of configuring the cells to the voltage and the capacity that I require, that I want. So we have a line here in the middle of these plans, and that line is to mark out the center of the battery pack, or the center of the bike. So I'm going to use this piece of aluminium, or aluminum, as the Americans would say. So I'm going to use this to mark out the center of the pack, like so. And I'm also going to use this orange highlighter and this yellow one to mark out the rear end and the front end of the bike. So imagine this here now, this orange highlighter being the front wheel of the bike and the yellow one being the rear wheel of the bike. So this is the position where I want the battery pack on the bike. So I will get onto that in a minute, what I mean by that, because this is not a basic battery pack here. It's quite complex, and the shape of it is quite unique to fit the bike, so it can't be turned around once it's made. So what I have here now is 10 parallel grips at the right hand side of the battery pack, and I also have a mirror image, so I have 10 more parallel grips on the left hand side. So I'm calling this bank 1 and this bank 2. So when I say I have the rear end of the bike here and the front end of the bike here, so I want the series connection where the bank 2 and the bank 1 are joined together at the higher end of the bike. I want the terminals of the battery closer to the wheel. So as you can see here, we have the 0 volts on the right hand side, and we have the 72 volts or 84 volts at the left hand side. So just going to now briefly discuss these plans, and then I'm going to move on to start actually, what do we see if I can get a drawing here or an image. I'm going to start configuring the pack using these printed images of the bike that contain 100 cells within the frame, within the Y frame. So I have a capsule made for this. It was the past video that appeared on my channel. The next video that appears on my channel after this one will be the actual building of the battery pack, the 2 banks. So I will be using the capsule, and all these cells will be uniquely placed within the capsule to form the 2 packs or the 2 banks that will be joined together at this point. So back to this now. So as I say, this is the middle of the pack, this piece of aluminium, and this is the front end of the pack, the front of the bike, and the rear end of the bike, or the rear end of the pack. So we have the first string starting here at 0 volts, working its way up to the top of the bike. Then we have it here joining in series to the 11th string. So this then will be on the left hand side of the bike, and it will make its way down the cell groups to give us 72 volts. So basically it's like having 2 36 volt batteries in series. Okay, before I continue with the configuration of my pack, I want to briefly touch on the cells that I have selected for the pack, but also the maximum current and the power of the pack. I think it's important that I cover this to avoid any confusion throughout the rest of the video or the entire e-bike project. So I have decided to use this popular Samsung 21700 cell. So 21700 is the type of cell, so it's the dimensions. 50S being the model, so there's a 50E and there's a 50S, the 50S being the more modern one, shall I say. So the reason I selected this cell over other cells is because, well, when you see the word Samsung, you think of high precision. So it's a respectable brand. I didn't want to go for anything over AliExpress or anything Chinese. So the second reason I went for the cell is because it has a high capacity of 5000 milliamp hour. The third reason, and one of the main reasons I went for this cell, is because they offer a robust discharge rate. So going by Samsung's datasheets, the standard continuous discharge current is 25 amps without temperature cut. So that's continuous current that can be drawn from the cell. The maximum current, the maximum discharge current that can be pulled from the cell is 45 amps. So that's with an 80 degrees Celsius temperature cut. So outside sources have stated they have tested these cells where temperatures of 90 degrees are visible at 25 amps. So that's going against the data sheets, that's saying different. But I will be the judge of that. I think the pack design plays a crucial factor here. So the fully charged voltage of the cell is 4.2 volts. The nominal voltage is 3.7 volts. Are all cells of this type. So I have stated here previously with this diagram that the voltage at the terminals of this pack will be 72 volts. That is nominal. And the voltage charged will be 84 volts. So 72 volts nominal, 84 volts fully charged. Okay, so the rate of current, or the current I intend to draw from my pack, will be as follows, using these Samsung 50S cells. So let's say I draw or pull 25 amps, which is the continuous rate from each individual cell within this configuration seen here. So across each branch of cells I would have, across one cell I would have 25 amps, and across 10 cells I would have 250 amps. So that is continuous current. So again, the configuration of this pack, 20 in series, 10 in parallel. The 10 in parallel is coming from here. So this is across one cell, 25 amps. If I multiply that by the 10 cells in the parallel branch, that equates to 250 amps continuous current. So let's say now that I wanted more power and I decided to max out the cell at a rate of 45 amps for a short burst in the same configuration. So across one cell I would have 45 amps, and across the parallel branch, 10 cells in parallel, that equates to 450 amps. So that is the pack maxed out with the temperature cut. So again, this is the largest discharge current I can draw from my pack at any time. So it's very important that I rate each one of the series connections between each one of the parallel branches to meet whatever I desire to pull from my pack. If it's 250 amps, if it's 450 amps, obviously it can't be no greater than 450 amps, but just to reiterate here, that 450 amps is only for short bursts with the temperature cut. So I'll just mark this out. So across each one of these series connections, or this series connection going between bank 2 and bank 1, or between the 10 string and the 11 string, I need to be sure that they are rated to handle 450 amps. So hopefully that makes sense. So I'm going to move on now to the power of the pack here. Okay, so the power of the pack will be, so at 250 amps and at 450 amps. I'm going to work out the power of the pack when I am drawing 250 amps from it continuous, but also when I'm drawing 450 amps max. So I'll just write that out here. So the voltage of the pack will be the 20 cells in series times the voltage of the cell, which is 4.2 volts. So that is 84 volts. So now using the power formula, I can find the power of the pack at 250 amps and at 450 amps. So 250 amps times the voltage of the pack, the maximum voltage, that gives me 21,000 watts or 21 kilowatt. So that's at 250 amps. So let's say now I want to find the power of the pack at 450 amps. So 450 times 84 volts, again maximum voltage, that equates to 37800 watts, which is 37.8 kilowatt. So these values are in an unreal world. There will be a voltage drop across the cells. So the higher the discharge current, the bigger the voltage drop will be. So let's say that I take the voltage drop into consideration here. So I'll say a value 3.5 volts. So that is the voltage across the cell when I'm drawing 250 amps. And let's say it's 3.4 volts at 450 amps. So if I now put these into the same formula, so 250 amps times 20 in series times the voltage off the cell, 3.5. And I also put it into this formula. So 20 in series, 20 cells in series times the voltage of the parallel branch. Speaking about cells there, the voltage of the branch itself. So that will be 3.4. So 3.4 at 450 amps. So the power of the pack, the real power of the pack, will be 17.5 kilowatt at 250 amps. And at 450 amps it will be 30.6 kilowatts. So you can see the difference there from the real world to the non-existent world. So this is because of the voltage drop across the cell. Obviously the cell's not going to stay at 4.2 volts under load, so there will be a voltage drop. So these values here I have set to mimic the real world. So the power of my pack should be around 30 kilowatts. So the maximum power. I'm going to move straight on now to the grouping the cells within the bike frame here. So I'm going to change this over. So what I'm going to do now is mark out, well, first things first, we'll go back this a wee minute. So I'm going to mark this, then I will explain what I'm doing. So purple, I'll start off with purple. Then we'll go yellow for the second string. And then we'll go orange. Purple, yellow, orange. Purple, yellow, orange. And then we have purple. So what I'm going to do now is move over to this printed image of the bike. So just ignore the position of the polarity. I'm only using this to configure the pack. So when I go to build my pack, I will turn the cells to follow the instructions that the plans that I now create. So I'm just going to mark this side too. So you will see why I'm doing this in a moment. Trying to keep this simple. Make it easy to understand here. Okay, so I've marked out my different groups now. So there's 20 groups, 20 parallel groups. So I'm going to jump over now to this image. So this is where the work begins. So what I need to do here now is start off and mark this out. So I need to just figure this out a moment. Okay, so we have 4 images here. So what I'll do here is I'll mark these out to avoid any confusion. So I'm going to start off configuring the right hand bank of the pack. So I'll call this the right bank. Right bank would be okay. And I'm going to say it's the right hand side. Okay, and I'm now going to mark this one out, and I'm going to say this is the left hand side of the right bank. So if you can imagine now, if I do this, this is one bank. So if we're looking at the bike at the right hand side and we flip it this way, this will be the center of the pack. So this is the right hand side bank. So the reason I'm doing this is because I'm going to sort of try and cover as much detail as possible here by marking out the buzz bar connections. So it's going to get tricky here, so I'm going to try and keep it simple. So move on now to the left hand bank. we're going to mark it out just. So this will be the left hand, what do we see? The left bank, but it's going to be the right hand side. So this is the middle of the pack. So in between the two banks. And what do we see now? If I get another one here. This one is going to be the left bank. It's going to be the left hand side. So again, if I do this, this will be the left bank, the left hand side. So this will be where your legs positioned on the bike, and this will be the center of the pack. So in between the two banks. So I'm going to mark this out now. I'm going to start grouping the cells here. Bit of work. So I'm going to start off with the right hand side. Then we're going to move to the right bank left hand side. So center of the pack. So start off here. So what I'm going to do here now is link this plan up to this right bank. So I'm going to call this right hand side face, just so we don't confuse things. So this is the face of the right bank, and it is the right hand side face. So I'm going to start configuring this now to match this bank number 2. So remember I mentioned there that I'm going to place the terminals. Well, I'm going to configure the pack so that the terminals are at the lower end of the bank seen here. So 0 volts will start here. So that will be at this point, and this is where the first string begins, the first group. So I'm now going to start grouping these cells into groups of 10. So there will be 10 groups, 10 strings. The 10th string will end up here, and it's the 10th string that will be connected to the 11th string on the other side, the left bank. So hopefully that makes things clear. So I'm going to start here now. So when I'm grouping these cells, I'm doing this on my own initiative, my own experience. So it's important that I group the cells. So say when I'm linking the two different groups together, I need to make sure that I have enough cells interlinking each other. So I'll explain that better when I start marking them out here. So I'm going to start here with this first string, and we're going to start marking the negative polarity here. So that's one group complete. I'm also going to highlight them, so you can see now why I use the highlighters on this plan. So hopefully the permanent marker is dry at this stage. I'll not go over too much. 2 swipes. So this now corresponds with my plan. So the first string being purple and this being purple. So as I say, the next group now I will mark using my own initiative, my own experience. So it would be very stupid of me to start running the next group up this direction using, just say, this is hard to explain. So in the other end of the pack there will be a copper connection. We want this copper connection, so this will be the series connection seen at this point. So this series connection needs to be sufficient. It needs to be rated enough, high enough to carry the current. So rather than try and interlink two cell groups together, 2 parallel groups together, I'm going to try and keep 3 cells connected between each parallel branch, if that makes sense. So going to mark out the second string here. So This is going to be positive polarity facing us. So I'll go up this way. Try not make a mess here. 1, 2, 6. That's perfect. So if you look here now, you can see how these cells, when they're crisscrossing. So say if I was to place a copper connection from here to here, here to here, and here to here. That's covering 3 places. That's quite broad. It's not narrow. So that will not be done at this side. But I'm not going to get into that at the minute. I'm going to keep just gripping the cells. I don't want to confuse things. So what I'm going to do here now is mark the yellow to match this plan. I should probably wait a wee minute because the permanent marker hasn't even dried. I'll keep her lit for this video. Okay, so that's the second grip, the second string complete. So now I need to move on to the third string. So I need to select these cells wisely. Okay, so I'm going to go down the way this time. So these cells will be negative facing us. The negative polarity. There you go. So there's 5. What do we see? 1, 2, 3, 4. There's 4 cells this time interlinking. So that's important. At this side. I'll not get into that at the minute, but I'll keep going. So we're going to mark this off in orange. So this is the third group. Completed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. So now I need to move on to the fourth string. We're going to mark it out first with a marker. So I need to be careful here. Okay, I've got it. I think I do. What do you see? Aye. We'll go the same again. 2 rows up. Perfect. And we'll mark that off. Purple to match the plan. At this point. So the highlighter helps here when at the next stage when I'm looking to mark out the buzz bars. So now marking out the 5th string. So this time I'm going to 1, 2, 3. Okay, I've got it. We're going this way this time. Because we have one less here, we're going to select one here. So we'll mark this now to match the plan. So we're getting there. Hopefully I don't make no mistakes. So now we're on to the 6th string. 1, 2, 3, 4, 5. There we go. Perfect. And that will be orange. Actually, I'm going to let it sit a minute because it's not dry yet, the permanent marker. So we'll mark out the 7th string here now. 1, 2, 3, 4, 5, 6, 7. That's 7. Make my mind up what way I'm going to go here. We'll take this one and we'll go. Perfect. So we'll mark this out just so we don't confuse things with a highlighter. Yellow, orange. Yellow, orange. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we're going back to purple for the 7th string. Now we're moving on to the 8th string. At this point, positive polarity facing out. So there's 8. And what I'm going to do here is go for this one and this one. Could have went for that one, but we can always change it. It's okay. 1, 2, 3, 4, 5, 6, 7, 8. No, I think it's better there because we can crisscross here, here, and here. Not crisscross, but it's just a way of sort of minding me where the buzz bars will be placed. So I'm going to mark now the next grip and negative polarity facing out. This is a 9th string. 1, 2, 3, 4, 5, 6, 7 and 8, 9, 10. Perfect. So this now will be the 10th grip that I mark. The 10th string. 4, 5, 6, 7, 8, 9, 10. Perfect. So that's looking really good. So I'm going to mark with the highlighter now. I think that one's okay there. Yeah. Oh, nearly missed one. So that means that my buzz bar, it will, no, it's okay because it will cover it. Okay, so marking out the 9th string or highlighting. And now on to the final string, the final group, purple. Purple or pink. Okay, that's one side complete. So I need to do this now 3 more times. So what I might do here is go ahead and complete these, and then I will oh, one final thing. So at this point here, there will be 36 volts. And this is where my series connection will be connected to the left bank. So this cable might actually just go through this loop. I'm not sure yet if it's 16mm squared cable that I need to use or what it is. But what do we see? I probably will just go like this through here. One. There'll be no loop there, but it's just to demonstrate. So moving on now to the right bank, the left hand side. So the colours will be in the exact same place, but the polarities will be completely opposite. So I'll do this now. I'll keep her lit here till we get on to the buzz bars. I'm going to highlight it first, it makes things easier. So a mirror image. So this is the cell. I need to remove a wee bit of the frame of the bike. Not the frame, but this bracket. It's only like minute material needs removed. Okay, so there we have a mirror image. So what I need to do now, a mirror image of the colour. So what I need to do now, so these groups are the same. These two groups are the same because this is the same battery pack, the same bank. So right bank, right bank. The only difference is this is the left hand side. So we'll mark this out now, the polarity. So this should be easy enough now because I've got the colours done. So this will be now. So at this side, negative. At this side, positive. So I need to make sure here not to mess up. Looking good. I don't want to look at that now because that will only confuse things. Okay, there we go. So that's one battery bank configured. Ready for, well, the groups are configured. They're placed out even. So what I need to do now is finish this off, the copper connections. I'll do that in a moment, the buzz bars. First, I just want to confirm that everything's opposite. So here we have the positive polarity facing out at this point. Here we have the negative polarity facing in to the inside of the battery pack. So that is perfect. So on to the left bank. Then we'll do the connections in a moment. So hopefully this makes sense to everyone. So everything you see here corresponds with this right hand plan. The right hand side here, which is bank number 2. So yeah, right bank, right hand side. Perfect. Right, we're going to move on now to the left bank. Same process again. I'm just going to video a whole lot. I may as well. So I'm going to start off with same thing again. The side where your leg is positioned on the bike. So starting here, then we're going to move on to this one, which is the middle of the pack. So this is also the middle of the pack, the one I just done, right bank, left hand side. So these copper electrodes, what am I talking about? The copper buzz bars will have an insulator in between the two packs. So basically I will be doing this with the two packs together, like that, with an insulator, a barrier up the middle. So moving on now to this one. It'll make more sense when I have everything laid out in the ground and stuff at the end of this video. Okay, so moving on now to the left bank. So going back to the plan, the earlier plan. So what I need to do now is focus on the left hand side. So that's the strings from, or sorry, the 11th grip or 11th string to the 20th string at this point. So what do we see now if I turn this around this way? So as mentioned earlier on, both banks are the mirror image of each other. So if I go back now to the right bank, the left hand side face, or even the very first one, which is the right bank, the right hand side face. So you can probably tell I've upgraded this to face. So when I mean face, I mean this is what we're looking at when we're looking at whatever bank it is, right or left. So just to speed things up here, the grip cells, the colours, the highlighted colours here will be the exact same. So the grips within the bank on the left, the battery bank on the left, or the battery bank on the right, the cells will be in the exact same place, if that makes sense, the grips. So go back to this. So if we look here and we go to the first string, this grip tail, this parallel grip, will be exactly in the same place as the 20th grip, the 20th string. So we'll just start marking them out and it will make more sense. So what do we see? So I'll copy this one. You know what? I'll turn it around. Make things easy. There we go. So highlighters, where are they at? So I'll keep our left here and I'll start marking these out. So this is the right bank and this is the left bank. And these, the first string is in the same place as the 20th string. So remember, there's two banks here. There's two batteries, in other words. So here we go. I'm just going to turn this around because it's kind of awkward. And I'll just copy it. So that's the 20th string done. And I'll keep our left here and I'll finish this off. Okay, so that's that one complete. So what I'm going to do here now, just before I move on, I'm going to mark. So this is the left bank, left hand side face. So This is where we get the 72 volts. So my terminal will be at this position here. So right leg will be down this side, left leg will be down this side, and both terminals will be in this position and this position. So moving on now, I'm going to just mark this out, the polarity of the cells. So remember, at this side we have the negative poles of the battery, the negative polarity, and at this side we're going to have the positive. So I'll mark them out here. Flying now. So the highlighted colour helps. As you can tell, I'm flat out. Okay, complete. Ready for the connections. So I just want to demonstrate here before we move on. So this is the outside of both banks. So my series connection now will run from this point, seen here, and basically it will go boom to this point, to this grip. So that is the 11th string and the 10th string connected together, seen at this point. So see the way the both one's purple there? Working out very well here. So I'm trying to keep it as simple as possible. So at this point we will still have 36 volts, but when we get to this point, seen here, we will add another 36 volts on. So 10 grips will be added to this 36 volts. Perfect. So what I'm going to do here now is finish the left bank. So this is the inside of the left bank. So it's all coming together now. So what I need to do here now is do the exact same thing I done to the right bank, the same process. So I'll need the highlighters. So I'll start off and left bank, right hand side, yeah. So a mirror image of this, well, the colours, well, the cells are obviously in the same position. So we'll mark this out first using the colours. I think it's better to use the colours because you can see things much better here. You can see what's going on. If I wasn't using these highlighted colours, it would be very hard to explain. Let me tell you that. So I'm flying again. We'll keep our lit. Uh-oh, it's running out. So 10 cells per grip. Worked out really well there, hey? There we go. So now I'm going to mark the polarity of the cells. So remember, this is the inside of the pack. So left bank, right hand side, the centre of the pack. So basically it will be the opposite. The polarities will be the opposite of where your left leg rests on the bike. So the opposite end of the cell. So starting with negative here. So this will be the same as the, what do we see? This will be the same as the right bank, right hand side face, sorry. So I can copy it. So these plans will be really handy when it comes to placing the cells, what do we see, in this capsule. So it's sitting beside me actually. Okay, so I'm now ready for the connections. We're going to start with the right bank. So this belongs to this one. So this here is basically the left bank. the cells marked out within the frame of the bike. We'll leave that to one side for now, and I'm going to start with the right hand side face. Okay, so I'll try and keep this as neat as possible. We don't need the highlighters no more. Okay, here we go. So remember, this 0 volts is connected to, what do we see? This point. Here we will have 10 cells in parallel. I'll try and do this nice and neat here. So that's one copper buzz bar. The next one now will be second string to third string connected together. So, at this side it will be second string connected to the third string. At the other side of this pack, on the other image, we will have the first string connected to the second string. So that makes sense. So here we go. I'm trying to keep this neat, but so there will be a gap between this copper plate and this copper plate. So now on to the next set. So there we go. And finally, on to the next group. Okay. So at this point where there's really only 2 cells crossing over, what I can do here is double up on the copper at this point, or I can just add another bit of copper coming along here. Well, that won't work, so I'm going to have to double up on the copper, or use, say, 2mm copper as the buzz bar rather than 1mm. So now on to this point. Okay, so that's one complete. It's not the tidiest, but it's okay for this video. So just want to point out now, so this last plate, this last group even, will be one plate over 10 cells. So there will be a series connection, a terminal at this point where I can connect on a high current cable, tri-rated cable, so I can run it through the bike frame to the left bank. So we're going to mark out the rest, and then I'm going to wrap up here. So came together very well. So the left hand side face, it will be identical to this one. So I'll just mark it out here. Sorry, I'm wrong, hold on. That's the right hand face. So this here is, this is the complete opposite actually. So if we look at this now, these 10 groups now will be connected to the second string on the inside. So I'll just go back to this plan. So basically what I'm doing here is connecting the second string to the first now. So hopefully you understand what's going on here. I thought this was the left bank. I'm lucky I didn't make a mistake. So all these positive cells, these purple ones, are being connected to the second string, the second group here. So the next one that I'm connecting now, the third, the orange to the purple, the third to the fourth, first to the second, third to the fourth. So a gap up the middle of this, these 2 copper plates, buzz bars. Now I'm on to yellow to orange. Yellow to orange. I'm on to what do we see? The 16th to the 15th are being connected together. So if we look here, I've done this one, I've done this, I've done this, and now I'm doing this 16th to the 15th. So a gap up the middle here again. Now I'm on to the 14th to the 13th. And finally, I am on to the 12th string to the 11th string. Well, sorry, I'm working on the wrong side. I'm on the 9th string to the 10th string. So, you can see the difference here now. I'll finish it first. Okay, so if I look at, I'll try and get them both on the view here. This is the same battery pack, the same bank. So the connections are completely different on the other side of the pack or the bank. So if you look here, you can see that these two groups, what do we see what number they are? Group number 9 and 10 on the right bank, yeah. So group number 9 and 10, on the inside of the bank, they are connected together in series. On the other side, the connection is only, well, there is no connection between 9 and 10, but there is a connection between the 10 and, what do we see? The 10 and 11, using the wire or the high current cable going down at this point. So I'm going to finish off the other bank off camera because it's exactly the same as this. Well, I'll just show that. Let me see if I can get them here. So I know it's kind of confusing, but it's not that complicated when you study it a wee bit here. So this will be the same. Okay. So the plates at the left bank, left hand side face, and the plates on the right bank, right hand side face will be identical. So I'll just draw a couple of them here and then I'll wrap this up. So here the terminal 72 volts. If I go back to the plans, at this point where the terminal comes into the 20th string, this string is connected to the 19th string on the other side. So I'll just draw this to show what I'm talking about. Okay, so there's where the 72 volts has been taken off. Well, the terminal will be connected at this point. So the 19th string now, yellow here, is connected to the orange. To the 18th string. Orange, yellow. Might just keep her going here just to demonstrate that there's two sets of plates are the same. Well, there will be two plates of each. So if we look at this now, we can see that these plates are identical, mirror image, and these ones are, when I say plates, the buzz bars. So I'll just continue on drawing it actually because it's not hard. Just for this demonstration. So we're working on the left bank now. So this is the left hand side. So I don't need this, but I'm just going to use it. So now we have this grip, this purple grip is connected to this yellow grip. So this is the 14th string is connected to the 15th string. 14th to the 15th. Is that right? Left bank? Yes, it is. Okay. I'll just draw a wee line up the middle of this. A gap up the middle between these buzz bars. So now I'm on to this one. Okay. Now I'm on to orange and purple. 15th string to the 16th string. Orange to, what do we see, am I right or on? Orange, where am I at? 1, 2, let me just start from the beginning. That, they have my colours mixed up. Purple, I'm working on the wrong side. Okay, purple, yellow, I knew I didn't make a mistake. Purple, yellow, orange. Purple, yellow, orange. So orange now is connected to purple, which is 15th to the 14th string. Big chunk of copper. So these will be cut out on a laser machine. The inserts, there will be square holes in the centre. Let me see if I draw this here. There will be square holes in the centre of where they're going to be welded to the cells. And what we'll have is a wee insert like this. See if I can draw this. Like that. Well, you're not going to see that. Like this. And these will be welded to the copper plate. And here will be a wee line to let the weld the current. So these are properly welded to the cells. So this line's actually important for the welding process. And we'll have the cell like this. And these inserts will be placed into the buzz bars. So I'm going to make a machine to form these inserts. So I'll demonstrate that on the screen right now. So moving on again, just finishing this up. So yellow now to orange. I'm going to just make sure I'm on the right side. Keep getting mixed up. The left hand side, sorry, bank 1, which is the, left hand side. Bank 1 is the left bank. I should have said that there in the start. I wouldn't have been confusing myself. Okay, so we're going to connect these ones. So a big run of copper there. As I say, because, what do we see if I draw this first? Because there's only two cells really interlinking here, I can spread this copper out this way to allow for that. Or maybe a wee bit out this way. But what I'm going to do at this point is basically double up on the copper. So say if I place, just say my buzz bars are 1 mil, I'm going to maybe have them ones at 1 mil and this one at 2 mil. So hopefully that makes sense. So we'll finish this up, or finish off here now. So this last one is basically, is it a dead end? So at the other end here of this grip, we will have this one connected to this grip. So at this point here, we will have a terminal and the wire going through, and that wire will meet, or that cable or wire, tri-rated cable, will meet the right bank. So those plates are identical, as I say, as you can see. So I'm just going to finish the other one off because I've done them ones. May as well. So these plates will copy. Sorry, I knocked the cell over there. I have too many bits of paper here now. So these plates will follow the plates on the right bank. So basically they will be connected like so. I'm not even going to draw the gap up the middle now because it just messes it. Okay, so I'll just go back to this for 2 seconds. So left bank is left bank number 1. Yes, so number 1. We'll just mark these 2. Okay. So now going back to left bank 1. So if I go back to this bank 1 and I go to yellow and orange. So from the terminal side down, so purple, yellow, orange, purple. yellow, orange. So what I'm connecting together now is the 16th string to the 15th, or the 15th to the 16th at this point. And now I'm connecting the 14th string to the 13th string, or the groups. So I can't really have the copper plate pushing up or exceeding up this way too much, because it would end up colliding with the strut. We don't want that. Complete. That's me finished describing this procedure. I don't think I've done too bad, because it's kind of a lot of work on it, but I'll set these out on the floor now and I'll discuss them a couple of minutes, and then I'll wrap this video up. Or I'll just do it here. So we have the left bank one. We have left bank one. So this is the same group of cells, right? And what we have here is the 72 volts coming out the lower end of the left hand side of the bike. Then we have the copper plates connecting the strings or the grips together in the correct manner. So they correspond with this. So if we go to this, these plates should be completely different from these plates on this bank number 1. Okay, so I went and done everything again out on A4 paper rather than the A3. So I'm just going to give a wee quick overview of everything, and I'm going to finish this video off. So on the left here we have the plan that I created to set or to configure my battery pack. So the cells I'm using, as I mentioned at the start of this video, are high capacity cells. Each cell is 5000 milliamp hour. So if we take this into consideration with respect to this parallel branch, 10 times one of those 50S cells gives us a 50 amp hour battery. So then I have 10 parallel branches, 10 cell groups on the left hand side here, and 10 on the right hand side. If we can imagine this looking down on the bike, or this being the front of the bike and this being the rear of the bike. So as I say, we have 10 groups here, 10 groups, and that gives us 20 groups in total, and that gives us 72 volts. So 72 volts nominal and 84 fully charged. So briefly now on to the configuration that I have set here within the frame of my bike. So in the next video that follows, I will be using, let me see if I can get it here. I will be using this special stainless capsule that I have created. I'll get some cells here to place my cells into the capsule like so, and in turn it will create the shape that I require for the green bike sitting behind me. So just going to finish up here. So as I say, I've done these out again. Nothing has changed. Everything is the exact same. So I have the numbers now of the connections between the strings. So for example, if I start, what do we see? So here we have the left bank. So this is the left hand side. So here on the left hand side of my pack, we have the terminal 1, and then we'll have terminal 2 on, what do we see? This point, this is mixed up. This should be down here. So here is terminal 2, which is 0 volts. And we have the different grips going through the pack. So at the top of the bank 1, the left hand side of the bank, so this is nearest my leg on the left, will have a series connection running through to the right bank, which is bank 2, marked here. And this series connection will join directly on to this grip, which is string number 10. So everything's marked out there. I'll zoom in nice and close here just to show the strings, the grip, the numbers. So just to point out, none of these configurations, these numbers, should be the same. So I'll bring the camera nice and close and then I'll wrap this video up. So, as you can see, much neater this time. So we'll have the main voltage taken from here and here. We'll have the copper plates between string 16 and, what's that say? 16 and 17, 14 and 15, 12 and 13, and 11. 11 will be connected to 10. On this side, on the right bank 2, we have the configuration 2 and 3, 4 and 5. So this is the connections, the series connections. 6 and 7, 8 and 9. And these images are the middle of the pack. So we have the strings connected 1920, 1817, 1615, 14, 13 and 12 and 11. And on the right bank we have 1, 2 connected, 3 and 4 connected, 5 and 6 connected, 7 and 8 connected, 9 and 10 using these copper plates. So one thing just to point out here, these plates are identical to these plates, but the inserts will need to be placed in the opposite direction. So hopefully that makes sense. So that's it. A lot of describing in that. So I'm just going to show this capsule. So this capsule came in the previous video. Oh dear, I'm showing something I don't want to show on the screen there, so I'm just going to blank that out actually. That's my smart gloves on the left there. So this is now complete, ready, everything's set, and I have the cells ready here. Let me see. I have the cells all ready. There's 2 boxes of them. They're genuine Samsung cells. And I can't wait to get this sorted. So one final thing before I move on here. On screen now is the little system that I will be designing. Well, I have designed it. That I will be manufacturing to build the inserts for these copper buzz bars. So that's it. Hope everyone enjoyed, and I hope everyone enjoyed my video of my stainless capsule. So this stainless capsule mimics this bike frame. So if you haven't seen that video, do get a look. It's the last video that came on my channel. So that's it, everyone. Okay, so I hope you enjoyed this detailed video. The next video that follows will use these plans that I have just created and the stainless capsule itself to start building this large beast of a battery pack for the Green Beast e-bike build itself. Finally, at last, this will be the start of this custom one-of-a-kind e-bike project. If you want to see this project evolve and other unique and world-class projects like this one, or if you want to see things done differently on a different level, please subscribe and hit the post notifications bell to see all the latest from my channel. Thanks for watching, everyone, and goodbye.